Okay, everybody, let's wrap up the cubic controversy and get you a little more information for how to solve some cubic equations. So on the last video that I made, I was talking about Cardano's solution. And I think that I mentioned that what he wants to do is to reduce any cubic he can find to the form y cubed plus py equals q. And for whatever reason, sometimes it'll be written like this, but for our purposes, sometimes we want it to equal or look like x cubed plus px equals cubed. Those are really pretty interchangeable. The reason we like this way, I think, is because nowadays we use x as our independent variable, so we want to solve for x a lot of times, those kinds of things. But you can clearly see those are basically in the same form. The idea being that I need to figure out what my p is going to look like and what my q is going to look like in order for me to really be able to utilize what he's going to do for us. So what did he do? Well, basically, all of our cubics we know are going to start as, and I'm going to switch to the x because that's what we're used to dealing with, right? So x cubed, sorry. I want to know if we used this format before. We did. We used ax cubed plus bx squared plus cx plus d equals 0. That's what I think we were using in our notes the other day whenever I was talking about, when I was talking about Cardano. So we're going to start out looking like that. And basically, there are two basically different techniques that he ends up using. I'm going to show you one really in depth, the way that your book does, and then the other one I'll just kind of leave it to you to think about and see if you can figure it out. But I'll give you lots of hints, don't worry. Okay, so what Cardano said was, look, I know I want it to look like this up here, and what I'm going to do is I'm going to make some basic substitutions. So he said, for instance, I want to say a cubed minus b cubed is equal to whatever my whatever my q value is. So he wants to make that basic substitution. And then he says, okay, I'd also like to say that AB, so A times B, is going to give me, 3AB. I'll make it shorter in a minute. 3AB is going to give me my p-value. It ends up that we don't really like it in this format because we want the A and the B by themselves. So what he ends up doing is making this AB is p over 3. So he's going to use these two basic things. And when you do that, he's going to take that particular system of equations, this guy with this guy, and he's going to try to solve for A and B. Okay. Now we can kind of look at that and say, oh, that's kind of ugly. I don't like the way it is. And basically what he wants to do, Cardano wants to do, is kind of get rid of some of the terms in there. So he wants to go ahead and work things out and see what's going on. So for instance, if I've got a cubed minus b cubed, then what can I do with that to kind of make it look similar to the AB guy? And what he came up with was, oh, look, I've got this guy right here, and I want to square this one. So square the first equation. That'll give me stuff that has 6's in it. And then this one, it'll give me 6's in it, and then I'll get some special stuff in the middle. I'll show you that in a second. But this one, if I cube it, then it'll give me powers of 3 on the A and the B. And so he's going to do a special combination whenever he starts working with this system of equations. So what's it look like whenever I square this first equation? Well, what Cardano comes up with is, okay, let's square that first guy. I get a to the 6th minus 2a cubed b cubed plus b to the 6th is equal q squared. Okay, and what he's really after here is this middle term right here, because he realizes that if I can get that to be an a cubed b cubed, then whenever I cube this guy up here, I'll also get an a cubed b cubed guy, and then I can manipulate this entire system of equations and get rid of some of the terms that I don't want, and it'll end up being kind of an interesting thing. Okay, so what's he do? Okay, cube this guy. Well, that's going to be a cubed b cubed, right, is equal to, whenever I cube the right-hand side, I've got p cubed over 3 cubed is 27. And he kind of goes, I don't like the way that looks. I'm going to do a really weird manipulation on this one. And what he does is he multiplies both sides by 4. Okay, so the 4, it's not going to do much for me here. It gives me an unusual coefficient, 4 over 27, that I have to manipulate a little bit in a weird way later, and that's not too terribly bad. But what this does for me over here is whenever I add those two terms together, I get 2a cubed b cubed, right? So and it's positive. And on the right side, of course, I've got the q squared plus, because he added two equations together, right? He's trying to kind of do an algebraic manipulation. If you were teaching an algebra class to high school students, we might call this the addition method or the elimination method. So he's kind of invoking that process before we really have that process to evoke, right? So he's messing with it just a little bit. But whenever he adds together these guys on the right side, he gets q squared plus 4p cubed over 27. When he adds together these guys on the left side, the a to the 6 and the b to the 6 just drop down, and this becomes a positive 2a cubed b cubed, right? Okay, so he's got this going for him, and he says, oh, well, let's take the square root of both sides. Sure, why not? Everybody says aloud, right? But whenever he does that, if you look at this guy on the left-hand side, the reason he wanted that 2ab, right, or 2a cubed b cubed, the reason he wanted that is because he can rearrange this into a cubed plus b cubed squared, the square root of that. So this b to the 6th, a to the 6th helps me. It's a nice little application of like a perfect square trinomial here, basically, that I can square that binomial and make it look nice and pretty there, or at least prettier than it was. And then on the right hand side, he says, I don't really care what's going on there. You're just going to kind of hold on to that, and it goes along for the ride. Okay. And notice that we're not doing plus or minuses on our square roots. We don't need to yet. They're not really recognizing these negative roots yet. So what happens over here on the left-hand side, of course, we all know that the square and the square root are opposite operations. And so what falls out is a cubed plus b cubed is equal to all this stuff. Okay. So that's the basic idea behind his manipulations. I'm not going to do a ton of work with this. You can look in the book and see what they do. There's a lot of adding and subtracting back and forth, a lot of manipulation, and he does this repeatedly, and then he ends up with some terms for A and B, and what he finally comes up with, and this is, I would never want you to memorize this. You would be given this if you had to use it on a test. But he finally comes up with, look, what I know is that x equals the cubed root of, if I go back and I substitute in the a's and the b's, way back up there, right? Because we know x equals a minus b, right? From, way up here somewhere. I didn't write it down, sorry. But from the substitutions that he's making for the a cubed and the b cubed. Okay, so what he ends up with is, hey, if you can solve this for the a guy, cubed root of q over 2 plus, inside of there is another square root. I know it's lovely, right? Q squared over 4 plus p cubed over 27. And it's interesting to me that what you see falling out here is the 4 and the 27 that we had in here. So they end up being represented up there. So he's got that. And then he says minus, because I know my x is a minus b, minus the b term. But interestingly, the b term is really, really close to what we've already got. We've got the cubed root of, and it looks exactly like this, except that at the front I get a negative. Negative q over 2 plus, and then all the rest of that stuff is exactly the same. Q squared over 4 plus p cubed over 27. Okay, so this is his solution, and as you might imagine, just looking at this solution, this is the reason I didn't do this last week, is because this is kind of messy and ugly. Every once in a while, you'll come up with a really nice, pretty number where whenever these things subtract out, I think there's an example in your book maybe where these things subtract out and you actually get 2, okay? But that's not normally the case. A lot of times you'll get like 1.97 or something like that. So just be aware of that. Nowadays, we would totally probably round that to a decimal answer. Unfortunately, Cardano really doesn't want to do that, and so we'll end up with some interesting little radical solutions that we'll deal with. So that's where we're headed with that. Okay, so there's an example in your book. I think it's in your book. I don't think I stole it from a different book, but if I did, I apologize. But it says, okay, what we want you to do is use Cardano's method to solve this particular cubic, and we want to solve for x because that's our normal independent variable nowadays, right? Okay, so the first thing we have to do is remember that Cardano is using things in the format x cubed plus px equals q. Okay, so that's actually pretty nice for us. We like that. That means that our 6 is the p and our 20 is the q. No worries. So p equals 6, q equals 20. No worries. That's easy enough. We can deal with that. The problem becomes we got to stick it into this craziness up here, right? So it's actually not terribly bad. It just looks ugly. So, and again, I wouldn't expect you to memorize that. It would be somewhere on a test question or something like that. All right. So what do we have? X equals the cubed root of. Instead of q, we're going to use 20. So 20 over 2 is 10. And then plus the square root of, okay, now we got to be a little bit careful because q squared is 20 squared is 400, right? 400 over 4 is 100, right? Check me and make sure I'm doing that right. Okay, plus p cubed, well, p is 6. 6 times 6 is 36, and if I'm not mistaken, 36 times 6 is 216. I don't have a calculator with me, so I'm going with that. So let me know if that's wrong. 216 over 27. That should reduce down to 108. Oh, that's probably not the... If that's not it, then this is 256. Oh, dang it. That's what happens when I don't make complete notes. Let me do this real quickly. I'm sorry, guys. No, it's 216. Okay. 216 over 27. All right. Oh, I know what I'm doing wrong. In my head, I'm doing some math wrong. I should just not do that. It's all right. Stick with the notes, dude. All right. So then I have the minus, and over here I've got the cubed root of, and again, the only difference here is that negative sitting out in front. So it's going to be negative 10 plus the square root of, and this is 100, and what this should be, hopefully you've done the math by now, is whenever I divide that out, I'll get an 8. Okay, in my head I was trying to make it 108 because I knew what the answer was supposed to look like, and that was wrong. Don't do that. All right, so now we've got, it's not amazing, but it's doable for us, right? We can play with it. So x equals the cubed root of, it's 10 plus the square root of 108 minus the cubed root of negative 10 plus the square root of 108. Okay, and this is what I was talking about. Sometimes some of this stuff in here will fall out. So Cardano's not going to do that. Cardano's going to leave this as his answer in most cases. But I believe that you could work that out and get a decimal approximation. In fact, that might be a quiz question. So you might want to do that. Approximately what? Whenever you go ahead and plug that in, and don't forget about that negative sign that's right there. So while this one is a positive, this one is negative, so watch out for it because it's not going to be the same. This radical is not the same as that radical, clearly. So anyway, it's not really pretty, it's not really lovely, but it's doable. And we would like to see some more modernized stuff. What we notice about Cardano, there's a few things. So I'm going to move his solution set over. There's a few things about him. One is, what if he gets a square root of a negative number? Okay, that's not going to be the case in this case right here, because square root of 108 is larger than 10. Right? So, because the square root of 100 is 10. So this is slightly bigger than 10. So when I do negative 10 plus 10 point whatever this is, it'll be slightly bigger than 0, right? So the problem might come in whenever I subtract these guys out, if it were some kind of crazy number, or if this number right here in the square root is not larger than my negative guy. I'm going to have some problems because he doesn't want negative answers, and he certainly doesn't really want some negative answers inside of the radical. So this is scary for them. However, what's going on here is that Cardano knows that some of his solutions have the negative number inside of the radical. So Cardano knows I is out there. He knows it's there. He knows it's coming. He just doesn't quite know how to use the I, how to notate it, that kind of thing. There's no way for him to work with it yet, so he has no tools yet, like we do. That's his problem. I just don't know what to do with it. So, for instance, if he got something like 5 plus the square root of negative 15, and 5 minus the square root of negative 15, what on earth shall I do with that? It's really frustrating for him because he can see his solutions are there. He knows, for instance, that if I'm working some problem and I've got 5 squared equals 25, he also knows that it could be negative 5 squared equals 25. So he knows that there are some times whenever I get a negative answer. However, we're still not quite sure what to do with negative numbers. We're not sure what to do with a negative inside of a radical. We just don't know yet. It's scary. But those things are coming toward us in leaps and bounds. We're going to see them soon. It'll be awesome. He has an idea that he should have 2 solutions. For instance, for a parabola or a quadratic equation, he kind of knows that. But if I'm looking at something like x squared equals 25, we know that we should have some kind of a parabola thing going on here with 2 solutions. But yeah, what the heck am I doing there, right? So he's got that kind of an idea going on, but he just doesn't know what to do with it yet. Okay, so that's where he is. We've got a tiny bit of problem still in our, don't want to say notation, it's more like in our thinking that we can work with those things without fear of weird, the world will not explode if we have a -5 as an answer to that. Okay, so what else? I don't think, this may be in the book, but I don't think it is. There's another process. There are other substitutions that could happen, okay? And he saw that. So, for instance, one solution could be, instead of doing what we did earlier in making PB3AB, you know, that particular thing, he's like, there are other solutions, other substitutions that I could do. So again, if I have I think it's in y'all's book. I'm trying to remember where I stole this from. Sorry. If I have something like this, now notice that they're going to have a leading coefficient of 1, and so I've only got A, B, C. I don't have the D term in there the way that we do in the last problem that we did. But if I have something like that, then I think it was Cardano said, look, let's do this substitution. X equals Y minus A over 3. If we do that substitution and do a lot of manipulation, this is where I said I'm going to leave it to you guys to do some manipulation, then what I'm going to end up with here is x cubed plus b minus a squared over 3 times y plus 2a cubed over 27 minus ab over 3 plus c equals 0. And the idea on this one is, okay, so if I'm using this, then I can look at it as if this binomial here is my p, and this trinomial here is my q. Okay, so and whenever I see that, look, this is in the form that I want it to be, right? There's my ax, or my x cubed. There's my py, yay, and there's my q. So again, it takes it back into the form that he wants, x cubed plus py. This is a positive, or I'm sorry, this is actually negative q. This is on the wrong side of the equation, right? He wants the q to be over here. So because we have it moved over to the left-hand side, we have to realize that that's a negative q there, right? Because this is the form he really wanted it in. Okay, so he says, hey, you can make that particular substitution also, and it does basically the same thing. It drops everything down to where I've got the, x cubed plus py equals q. I've got it in that form that I wanted, that we talked about before we started everything, right? Okay. So that's what we're after. So lots of manipulation going on in there, lots of algebraic stuff going on in there, but, you know, it's kind of neat. It ends up getting us some solutions and going from there. All right, so what's this look like for you in a homework question? First of all, some of the homework questions tend to be written in a generic kind of term, so you have to maybe read them and interpret them. So it might be something like a builder had somebody build something that was 400 cubic cubits. Okay, so 400 cubic cubits is its space. Now, for us today, we'll know that that looks like volume, right? Okay, so the space, because it's the cubic units in there. Okay, if the length is 6 cubits more than the width, and the width is 3 cubits more than the height. This is old school language, right? Those cubits in there. Then what we want to know is, what are the measurements? And again, sometimes it's just a bit of the interpretation and making sure you read what they have and all that. So of course, one of the things that I want to do is figure out which guy is kind of my independent variable here, which is the height. So let x be my height. And then the other thing is, of course, we know whenever we're looking at these three measurements, this is volume, here's my volume here. That formula for a volume of a cube looks like V times L times H equals, equals area. For our purposes, that means that if x is my height, and if the width is 3 cubits more than the height, then that guy's going to be x plus 3. And if the length is 6 cubits more than the width, then that's going to be x plus 9, right? And my area is 400. So just kind of putting together a word problem that this is something you, again, would probably teach in an algebra class if you were teaching in high school. However, the wording and the way that it's represented is a little bit weird. We can see this is going to be a cubic equation, right? That's awesome. So if I multiply all that stuff out, I should get x cubed plus 12x squared plus 27x, and I'm going to go ahead and subtract off the 400 equals 0. And that looks like the kind of equation that Cardano started us with. So I've got my A, my B, my C, my D. That's awesome. And so you can go in and apply one of these techniques. In this case, because we've got it all 4 terms. Well, actually, this is a leading coefficient of 1, so you could use either of those techniques that I just went through, and they would work out fine either direction. I'm not going to work out this problem because I'm already looking at 30 minutes of recording time, and I've got a little bit more to get to you. So basically, let me throw up the answer there. I'll leave this for your practice. Practice example. Yay. Make those substitutions. There is a bit in your book about making the substitutions, so see if you can do that. Apply a technique and solve. That's what your directions should say. Solve for x. And I'm just going to give you the answer just so that you'll know what it should look like whenever you get there. It's really a lovely answer. X equals -4 plus the cubed root of 190 plus the square root of 35,757 plus the cubed root of 190 minus the square root of 35,757. So there you go. Lovely stuff, right? Okay. Also in your homework set, and I think I assigned some of this, but if not, just kind of make sure that you're looking at it. The author of your book wants you to realize that Cardano is stumbling onto excuse me, what we now call complex numbers, right? So the author of your book is wanting you to play with complex numbers and make sure, I know these are basic skills. Everybody should know them, so I'm not going to spend a lot of time on it. However, excuse me. Sorry, guys. However, if you do not remember how to do this, then you should spend some time reminding yourself of complex numbers and what the rules are, and that's why some of the homework looks like this. So a complex number is in the form a plus bi. The a part here is generally considered the real number part, and the bi is generally considered the imaginary part. And we know that this is where I is equal to the square root of -1. That's the generally that's the substitution that people make. There are some more specific ways that people write these things out, but normally speaking, that's the way we would probably think about it. So that's what we're looking at. So think to yourself, hey, can I add and subtract, multiply and divide? If you don't remember, pick two numbers, and it doesn't really matter what they are. Let's say 2 plus 3i and negative 5 minus 4i. That'll work. Okay. And see if you can add, subtract, multiply, and divide those out. And of course, if you're not sure, remember a couple of things. You generally treat I as if it was any other variable. So when I do I times I, it's I squared, that kind of stuff. But the other substitution you need to know, if you don't remember it, is that when I square this guy out on both sides, I squared, the square and the square root will reduce out, and I'll get a negative 1. So remember that if you have an I squared in your answer, we don't generally leave it as an I squared. Instead, we substitute it out for a negative 1. And then you might have to do a slight bit more of simplifying to make it look prettier, right? Okay. The other thing here is that in your book there are some problems where they want you to solve for x. And it's some kind of quadratic formula, quadratic equation. I don't care what method you use. The thing is, it's doubtful that it will factor because it's in this section. Most of those problems are going to end up probably with some complex number solutions. And so therefore, I'm going to say factoring is probably not a good thing. But if you wanted to complete the square, you could totally do that. We just had practice with that last week. If you wanted to do quadratic formula, you could totally do that. And again, if you don't remember those skills or it's just been a while and you're feeling a little bit weak on those, then go back and refresh yourself on those so that you remember how that works. Because these things, because this is in a quadratic method, this doesn't really relate back to the cubics that we're talking about here. However, it's a skill that you should have, and you should have a bunch of those solving techniques available to you, right? So if you have problems, be sure to just send me a message. I'll be glad to talk to you about them. Okay, let's wrap up this Cardano thing. What we know is that Cardano, the big controversy is over who owns the solution sets for cubics. And what we're seeing is that publicly publishing your results get you credit, even if you weren't the first one to do it. And so in today's modern academia at the university level, you may have heard something before that's called publish or perish. And it's widely believed that this comes from the cubic controversy, and also we'll see it again when we get to the calculus controversy in a week or so. So we can blame Cardano, basically. And the idea is if you're at an academic level, if you're at a university and you have some result that you have come up with, and you hide your results the way that Tartaglia did, then you're not going to get the credit for it later if you want it, because you should have come out with it. And if somebody else figures out your solution or adds to it or whatever, and then they publish, a lot of times you're going to lose ownership of your work, and people don't want to lose ownership of their work. So publish or perish. And they've taken it to such an extreme at the university level that if you're not publishing and you're in a tenure track position, that you can perish, as in lose your job. Okay, it's kind of extreme. So the tenure track gives you a certain amount of time. Usually there's a certain number of publications that they want to see, and usually that's, original work that they want to see. And if you don't do that, if you don't put that out there for your peers to review and to see it, then you are likely to lose your job. And so therefore we call it publish or perish. Okay, so that's something that'll kind of come up again. The idea here is that we want all the world to see this. We want to share, Haven't written in a while. We want to share. I've been doing a lot of typing, but not a lot of writing. Share our results. And if we have new math, which is what we're starting to see come out of Cardano, then we really want to share that, because goodness, if other people see that new math, then they can build on your work and make it better, and that's a collaborative way of thinking, right? It's not a selfish way of thinking. So yeah, we would really love to see all the new math. What else about Cardano? The good thing about him is that he covered all forms of the cubic. And because he didn't want to deal with negative numbers, so that's with positive solutions. Because he didn't want to deal with the negative numbers, he could have probably done some plus and minus kind of stuff or whatever. He actually went case by case by case with figuring out all the different possible ways that the cubic could be, and it actually ends up causing problems. The fact that we have new math, it's brand new, it's forward thinking, it's algebraic, and we're starting to get that great algebraic notation going on. What we see here is, this is why we call it the Renaissance of math. And it's kind of a freedom from the ancients. So all of a sudden, we're doing stuff that those ancient Greeks couldn't do, that the Egyptians didn't see. The Babylonians might have had some kind of an idea. Back, we had the Plimpton 322, right? We had for sure in the Plimpton 322, we had a squared plus b squared equals c squared. So, if you're talking quadratics, whatever, that's been done, right? But the cubics hadn't been done. Remember that, in fact, people, even just a few years before Cardano and Tartaglia, were saying, the cubic just can't be solved, right? So the other important thing or interesting thing is that there's also a solution to the quartic. It doesn't get as much press, probably because, now we've got cubics, that other stuff is just whatever, been there, done that. Now we know we can do new math. Poor Ferrari, remember he was Cardano's student. He was the one who came up with the solution to the quartic, and it's in Cardano's book, Ars Magna. I think I might have mentioned that before. But anyway, it's in there, and so now not only do we have the cubic solved, but we also have the quartic solved. So that is awesome stuff, and just newness is really awesome for these people. Okay. So that is mostly it for this particular part. I think the next bit that we're going to do is a separate chapter in your book. It's moving on to some names that you probably know, like Kepler and Galileo and Descartes. So these are much more modern mathematicians. I mean, they're still several hundred years ago, but they're much more modern. And of course, when we say mathematicians, we use that to encompass the science that we know Kepler and Galileo put out there for us, because they used a lot of math in there. So we're going to move on into that. We'll start with the Reformation movement of the Lutherans on the next video, and move into Germany and different areas like that, and a lot more modern stuff that you've probably seen a bit. All right, that's it for the cubic controversy. Whoa, cubics! See you later. Thanks. Have a good week.